So I think we can get going with the webinar. So welcome everybody. Thanks for joining us for our weekly webinars. So today's webinar is about Creo NC for beginners. So I just prepared a few slides to just get us going. So just a short agenda. So I'm going to do quick introductions, and then we're going to move on to the topic overview. So we're going to talk about the Creo NC setup and how to start the machining. So this is for beginners. So I'm going to sort of start at the beginning, start with the foundation, start with the setup on how to get your NC machine up and running using Creo NC. So just a quick introduction. So my name is Pierre Venter. I'm a PDSVISION technical specialist. Been working with PTC products since 2008, so it's about 15 years. So each engineer at PDSVISION specializes in certain areas of the PTC software suite. So I specialize in Creo manufacturing, smart assembly, top-down design. So any automation in Creo is sort of where my speciality is. So PDSVISION, so we are a global reseller and preferred service provider for PTC. So as you can see here, we have offices around the world, South Africa, North America, and then Europe, India, and the UAE as well. So just some of the capabilities we have. So we help our customers on a consulting basis with implementation services. We do professional training as well. We also have cloud solutions, and then we also have the help desk for all the products that we support. So just sort of a brief history of when we started and where we are today. So you can see we sort of started in 2006, 2005-ish, and then sort of started as Boundary Systems, and then PDSVISION Group bought us out, and that's why we are part of the PDSVISION Group at the moment. Just a quick history of where we are today. So some of the products that we specialize in. So I think the PTC product range is the main thing. We do a lot of PTC work. Then we have bits and pieces like KeyShot, ZWCAD, CMAX, and stuff, HRH, Tacton, and so on, just to name a few. But I think the main focus is the PTC products. Okay, so let's jump into the Creo NC stuff, the fun bit for today. So just a quick thing. Any questions? You can ask questions using the webinar question pane. Use that, and then don't wait till the end. You can get them in to me as soon as you think about those questions. Ask them. Maybe I answer them during the webinar. If I don't, then I'll spend some time after the webinar. But as soon as you think about those questions, get them into me. Just get you forget about them or sort of get sidetracked. So get those in. Okay, so I think the important thing when you're starting to work with Creo NC is to understand how Creo approaches these NC sequences, or how it will approach the workflow that you need to follow when you create your toolpath. So I think everything is integrated, everything is part driven, it's driven from the part, so you can sort of create your core and cavities from your design component. You can do tooling design from there, you can do jigs and features from that part design. So part centric is the main focus. So everything is driven from that. What's nice about that is if your part changes, then that's going to flow to all the other things that you've used. So if your core and cavity will update, tooling design will update, your NC toolpaths will update. So everything driven from that part that you've designed. So yeah, just keep that in mind. I'm going to show you one or two things during the live demonstration that's sort of going to just show you how to work on a day-to-day basis very quickly using Creo NC. But this is the main overview. Model centric, everything is driven from that model. So when you go into the manufacturing side of things, then there's a specific assembly type that you need to create, and that's a manufacturing assembly, an NC assembly. So these assemblies use exactly the same format as your normal assemblies. So you can have specified datum planes in there. You can have specific parameters. You can have layers set up in there. So everything that you use in a normal Creo assembly template, you can have in your NC template as well. So if there's specific things you have, like you can have a template for one type of machine. So you have a 3-axis machine on the floor, you can have a 3-axis template, and you can load tools and machines and jigs and features in there, and then you can just reuse that. Okay, so just remember the template starting point. Don't overdo it. Don't put too much things in there. So you can see on the model tree snippet that I have on the screen now, just a normal NC assembly, right? Datum planes, top and front, one coordinate system, and that's sort of my starting point for my template. And then from there on, you can sort of grow that template. So a few things that you must have in these manufacturing assemblies is you need to specify a work center. So you need to tell Creo what type of machine you'll be using to machine this component. So will it be a 3-axis milling machine, a 4 or 5-axis milling machine? Will it be a turning machine? Will it be a mill turn machine with multiple turrets? So there's many combinations that you can specify when you create that work center, but you have to tell Creo what type of machine tool you'll be using. So once you've specified that, then you can create an operation. So an operation is just a sort of a section where you tell Creo, okay, so I'm gonna take this operation, I'm gonna assign a machine to it, and I'm gonna assign a coordinate system to it, and that's sort of what that bunch is going to do. So that operation is going to control just that section. So you can have multiple operations in one assembly file. Nothing is stopping you from creating, let's say, a 3-axis milling machine, then a 5-axis milling machine, and then a turning machine as well. You can have all of that in one assembly file, and then have different operations. So if you do like machine hopping from one machine to another machine, you just have one assembly file and that you have to manage for that component. So everything there in one place, easy to manage. So for today, we're going to keep it very simple. We're just going to have one machine, and we're going to do some basic 3-axis toolpaths just to sort of get you guys used to the parameters and what they can do. So once your setup is done, you've created your operation, your machine is there, you've set the coordinate system it should use, then you can start creating your toolpaths. So each section, the milling and the turning, it's got its own sort of dashboard that you can use. So you can see the one at the top, that's our milling dashboard. The one sort of in the middle is our turning dashboard. So you can see your roughing, re-roughing, face milling, all the drilling cycles are there. And then also the high-speed milling, which is a separate license for the high-speed stuff that you can use. So once you start using those, then the feel between them are very similar. If you do a roughing, you can do a volume rough, or you can do a profile milling, and you can do a trajectory. The feel in those dashboards are exactly the same. There is one exception, that's the surface milling. Surface milling is still the old menu manager, but there's a lot of other tools there that sort of replace that and is just as powerful or even more powerful than the old surface milling sequence. Okay, so once you've created those toolpaths, then you need to get them to a machine. Okay, so for that we need to convert them, and that's where the post processors come into play. So the post processor will take the Creo CL data. So you can see in the middle of my screen, that's the Creo language, and that's sort of driving the tool within inside Creo. So there's no machine that's going to understand that language. That's specific to Creo. So we need a post processor to convert that to a language that the machines can understand. And there's each machine is different. There's certain M codes and certain G codes and things like that that needs to be activated. And then on top of that, there's user preference as well. So some customers might want the spindle command, the S on a single line, or they want it with the first or just before the X, Y movements, and then after Z, or something like that. So it makes it easier to read for the machinists, and it makes it easier to check. So that's everything that we sort of can do with the post processor. So we develop those in-house. I'm responsible for some of those, and then some of my colleagues will also help me out with those post processor development. Okay, then also something that's maybe a little bit newer in I think Creo 9, 10-ish is where you can have specific pprint commands, and you can use those to drive the post processor. So that's just an extra function that's fairly new in Creo, where we can set certain parameters and things. So that sort of begins to form part of your templates, and then that can make the post processors development a little bit easier and a little bit more flexible for the end user. Okay, so just quickly to recap, we're going to sort of start with the setup, how to set Creo up, then create those operations, the machines, and specify the coordinate systems. Then we're going to create some tool paths, make the machine move with certain tools, and then we need to tell the machine what to do, and that's where the post processor comes into play. So that's just the NC bit of the workflow. So I've prepared a short demonstration just to sort of show you guys how all of that will work. So let's jump into Creo, then we'll get to the other slides after the demonstration. Hide there. So I'm going to do it a little bit backwards today. I'm going to start off with, and I'm going to show you a completed model, and then we're sort of going to rebuild this so you can understand where we need to go with this. So let's quickly look at the model tree. So in here we've got our clamp, or this could be a jig or a feature or anything like that. So that was assembled using normal Creo functionality. Then we've specified a machine. So I'm just quickly going to edit definition this. So in this example, we're using a 5-axis machine. We can also look at the tools that was specified in this machine. So normally your first 5 tools will be fairly standard on the machines. So you can make that part of your template if you want to. You can see we have a few different ones loaded in here, some with no holders, and then some that's just specified in Creo. So these holders and tools, these are normal Creo assemblies that we've assembled, and we're just using them as tools. So there's one or two parameters you have to add them, like where the tip is, and then the orientation. Then you can use those assemblies in normal Creo NC as cutting tools. Okay, so let's cancel this. Just quickly want to show you the tool section, and this is the machine. So we're working with a normal milling machine here, and we've said it's going to be a 5-axis machine. So you can specify what type of machine this is. Okay, so we've specified our machine, then we've sort of assembled our cavity and core part. We created a coordinate system. You can see we're using the center of our workpiece. Notice the X, Y, and Z orientation. So your X, Y, and Z orientation, very important. Your tool is always going to approach from the Z direction. So keep that in mind if you're going to work with 5-axis machines and things like that. And if you're planning your setup, there's many options. I could have used the corner here if I wanted to calculate my tool path from there. I could have used the top surface over here and then maybe in the center of my part. A lot of guys like to pick up your workpieces on the machines like that as well. That's an easy one as well to do. Corners, also very popular, but then you need to check that your parts are straight on your machine. So always know where your path is going to be calculated from. And that coordinate system is very important. Okay, so we've got multiple workpieces in here as well. So you can see we've got for the core and the cavity. And then we have our operation. I'm just quickly going to edit definition this just to show you guys. So in the operation, we tell Creo what work center or what program 0 we're going to use. So that's normally your G54. That's the point that you will pick up. So you can see in this operation, we're using the corner over here. Okay, so that's our coordinate system. So that's an important one to pick up. And we can also set our clearance plane. So where's our clearance plane currently? Sitting over there. So just 1 millimeter, 1 inch above the surface. Okay, and then we're using the feature setup. So you can see this is the one that we use. So we're using that DL800 in the model tree. You can pick that up. We're using that one as our feature. Just going to cancel that. So then also a very important aspect is your mill windows. So mill windows, that's just a way of telling Creo where do you want a machine. So in this case, our mill window, edit definition, that is this section here at the top. All right, so we're telling Creo with that window, well, we want to machine the complete component, that part. What you can do with the mill windows as well, you can just limit it to a section, and then you can sort of just rough out that section, or you can just finish a section. So anywhere where you specify mill windows, you can sort of narrow it down and then just work on that area. Then you know clamps and everything is out of the way. The toolpath is not going to go near it. So just a method of controlling where your toolpath needs to go. Under this, you have the inside, or you have the how it should manage that boundary. So should it stay inside those contours? Can it go onto it or on the outside of it? Right, so that depends where you want it to go. Inside a cavity, you might want to keep it inside the window contour as well. So you want to make sure it's not approaching from the outside and then maybe bumping into your part or into a clamp or a vise. Okay, so that's sort of the setup. Then you can go into your tool paths. So let me edit definition this one first. And then hopefully I'm going to make it a little bit slower so you guys can just see how the tool is going to move. So in this case, we used one of those solid tools, those assemblies that I've assembled. And then that's sort of going to create the tool path for us. So that's just a quick simulation on how to verify the tool movements. I'm going to stop this and then just show the complete path. So you can see how it stays inside that cavity. Right, so it's not going out of it, and that's because of the mill window that we've used. So that mill window was just on these edges. So everything is staying in there. We're also using the high speed option here, so you can see that. Let's quickly change this to the top view. Then just zoom in for you guys so you can see that movement. So this is the high speed roughing sequence. You can see that a clean tool path. So this tool path, you want to sort of take the whole flute of your cutting tool and then just have small step overs. So you'll have like, excuse me, but I'm going to talk into millimeters. That makes sense to me. I'm a metric guy. So you'll take like 1 or 2 millimeter step overs, but you'll use the whole flute. So you'll dig that tool deep into the workpiece and then remove material quickly like that. Okay, so let's just quickly review some of the parameters. So you guys will notice that the parameters are very similar for all the sequences in Creo. So let's quickly edit definition. I take this high speed roughing. Then let's quickly go through the parameters. So when you click on the parameters tab, you'll notice a few default ones that's there. So cutting feed, step overs, some basic scan types or how the tool should move is there, your clearing distance, and then the spindle. If you click on the icon here at the bottom where all the parameters are, then there's a whole list of things that you can set. And they are very similar for all the sequences. So use your categories to sort of narrow them down. If you want to control speeds and feeds, so you can see I don't have free feed or plunge feed or pull out feed or any of those set for this particular component. It doesn't need all of that. All I need is a cut feed. And when I sort of do when I'm going to do it from scratch, I'll show you guys. These will be highlighted in yellow. So all the cut depth allowance parameters, the cutting motion. So if you expand that, you can sort of change them to whatever they need to be. Your cut type are all on the flyouts. You just basically click on them and then on the flyout sort of set them to what they need to be. Enter and exit motions, that's also a popular one. How do you want to go into the workpiece? So that's where you're going to set all of that up. Machine settings, coolant options, you want that on. Cutter compensation, do you need that on? Is it the left or right hand tool? You need to specify that as well. So all of these can be set up with the template and they can have default values. And then you just need to set those critical ones. But out of the box solutions will have like clockwise, and there's a default range that comes out of the box. If you need to adjust those, we adjust them, make it part of your template, and then you know you're right. Okay, so just to quickly prove my point, let's go to finishing toolpath. Let's edit definition, that one. And you can see exactly the same. We specify a tool, we go to the parameters. It's not going to be exactly the same. There might be slight differences because we're working with the finishing toolpath, but the feel of it is exactly the same for most of the sequences that you will create in Creo. Okay, so I just quickly want to show the simulation. So there's two ways to do the simulation. The one that I've showed you already, this one where you play that. I'm going to stop that. Then we also have the other simulation. Okay, and then I'm just going to start to play that. So here it's sort of taking the stock and everything, and it's just giving you a different view. You can see how the material is removed. Much easier to see what the end result will be using this simulation. You can also do collision reports, gouge reports. So if it's going to bump into a machine, into your part, or into a clamp, it's going to highlight it here for you. Okay, so that's sort of what I wanted to show you guys, just a quick overview of the completed NC assembly. So let's go and let's recreate this. So you're going to start with new. You're going to select your type as manufacturing, and then we're going to start with an NC assembly. I'm going to use my default template. So there's almost nothing in there, just a few datum planes. So let's use that. So there we are, clean canvas. So in our template, we have a right datum plane, top, front, and a coordinate system. That's it. So we need to do a few things to get our part. So there's a few ways that you can start this off with. In the other assembly, they sort of started with the clamp. That makes sense. You can use that if you know. Sorry, just quickly had to take a sip of water there. So you can start off with the features or clamps if you want to. You can start off with with your reference model, the part that you want to machine. There's many ways to do that. So let's take a different route. So they started with the clamp. I'm going to start with my reference part because I'm not sure what clamp I'm going to use. So I'm quickly going to go to my parts, and then I'm going to create, let's use the cavity part. And you're going to use your normal assembly methods. So let's say I'm going to take this bottom surface, I'm going to assemble that to my top plane, and that needs to be coincident. I'm going to take my side surface, that needs to line up with the right datum plane, that needs to be coincident as well. And then I'm going to take this front, align it up with that datum plane. Okay, so that's my reference part. So that's assembled. So that's just an accuracy warning that tells me that my assembly accuracy and my part accuracy is different, but it's going to adjust it to be equal. So you'll get that a lot of the times when you're working with imported geometry. Step files love to have different accuracies than what your templates would be. So try to keep them the same. It's just much better tool paths and everything just a lot more stable. So you'll see in our model tree now we've got our reference model in there. So the next thing we need to do is we need to create our stock material. So there's a few ways that we can create our stock material. I'm just going to use the default one now. We can adjust the sizes if we want to, drag handles, things like that, or type in the values. So it just sort of took the maximum X and Y and Z values, and it sort of created this block around it, and it's saying, well, that's our stock. Guess in the real world, your Z will be a little bit higher. You will have something like that. Okay. So I'm just going to take that back to 0 and say, okay, so now we have stock material, we have our part. What's the next thing that we'll need? We need to tell Creo what machine will we use. Okay, so we're going to go in the flyout. We can tell it we're going to use a milling machine, a mill turn machine, a lathe, or a wire cutter, wire EDM machine. So we're going to keep it simple for now. We're going to create a milling machine. On the fly out, we're going to use 4, 5 axis or 3 axis. Let's stick to 3 axis for now. If we go into tools, you'll notice that we don't have any tools in this template. So I don't have any of those solid tools. So I can bring them in from my library, but I want to talk about the library in the more advanced webinars. So we're going to keep it very simple now and just create tools as we go along. So I'm not going to create any tools here. I'm going to create those tools when we do the sequences. Okay, so I'm going to go cancel on the tool setup, and I'm just going to give it a standard milling machine number. So mill machine number 1. You'll see we have that in our model tree. So now we have our part that we want to machine. We have our workpiece. We have our milling machine. Now we can do our operation. So notice the tabs here at the top. I don't have milling or turning here. Okay, so once you've created an operation, you'll see the tab will be here at the top. So let's go to the operation. I'm going to tell Creo, well, I'm going to use machine mill number 1 and then a coordinate system. So I have a coordinate system over here at the bottom. So maybe I can use that if I want to. That makes sense. My Z is showing to the top, the X, Y. So it's sort of, if you're standing in front of the machine, it's going to sit like this on the machine. So yep, that coordinate system can work for me. If I don't want to use that coordinate system, I want to use the center or maybe this top corner. Nothing is preventing me from creating this coordinate system on the go. So I can go say coordinate system. I want to use this corner here at the top. I want to set the orientation. That top surface, that should be my Z axis. And then I want to use this edge. That should be my X axis, but you can see it's showing in the wrong direction. So I just flip that around. And this would be my G54. So which means all the toolpaths, all my Z levels and things will be calculated from that. I'm just going to resume my operation after I've created that, the coordinate system. I can specify my clearance plane here if I want to, but you don't have to. What I want to specify in here is my feature that I want to use. So I didn't do it like the sample assembly I had. So all I can do now is I can assemble that. Just going to set this to assembly, and I'm going to grab that vise. And I'm going to assemble it exactly the same way you would do with any component within Creo. So that surface should be coincident. Just drag it to make it a little bit easier for you guys to see. This surface here was probably my parallel on my machine. Should be on that. And then I'm just going to create a little bit of an offset. Just the distance to assemble that more or less in the middle of my part. Okay. If you have the exact values, use that, because if you put it wrong here, your collision detection and things might be an issue. In this example, it's not going to be an issue. I'm just going to machine the inside of my part. And we are happy. So there's our vise. That's part of our operation. And notice now that I've finished that operation, now I have my milling tab, which means now I can start machining this component. Okay, so that's the critical steps when you sort of do your setup. So once again, I've sort of talked about the mill window when I started off with the other assembly. I'm not going to specify that mill window now. I'm just going to start and say, well, I want to rough out this inside. And it's going to ask me, so what tool do I want to use and what mill window do I want to use? So those are things that I have to specify. So you will notice all of that is in yellow. So parameters that I have to enter is the cut feed, the step over, step depth, clearing distance, spindle speed. So those are critical things that Creo needs before it can create the toolpath for us. I also need to specify the clearance plane. So I didn't specify that in my operation when I created the operation. So now I have to do it in here. So let's start with our tools. So we're going to create a new tool. It's going to be tool number 1. You can give it a nice descriptive name. I'm going to make this a 20 millimeter diameter, and my flute length, they're normally around about 50 millimeters. So it's almost 2 inches for you guys. And I'm going to say apply. So that's going to sort of create that tool for me. If I want to create a new tool, just click on new. It's going to be tool number 2, and I can specify what type of tool do I need to make. So what's nice about doing this way, you will notice now that I can only create a certain types of tools. So I can only create a milling, end mill, ball mill, or a bull mill. So that sort of Creo narrows it down. I can't create a drill now because I'm busy with the roughing sequence. So you're not going to use a drill tool to rough out your part. So it's limiting your selections when you start with the sequence and then create your tools. And let's go for a bull. Let's go for 18 millimeters, and let's go for 50 again. I want to give it a little bit of a radius, and then say apply. So there we have an end mill for tool number 1, a bull mill for tool number 2 with different diameters. Okay. So we're going to use tool number 2. So the next thing that we need to specify is our preference. So that's the mill window. So now we need to tell Creo, okay, so where do you want to machine? So remember, yeah, it knows here's a part, but where in that part do you want to machine? So we can go here to geometry, and we can create our mill window. And within the mill window, we have a few options that we can use. So do you want to sketch it? Do you want to select the change? So I'm going to go pick the surface, and then I'm going to pick the edges that I would like. So I'm just going to take these outside edges. You just picked one, shift down, then it will grab all the edges for you. I'm not going to specify any depth options. So I could have done that. So let's say I want to use this 20 tool, but I only want to go up until a certain depth, then I can tell it. So don't go more than 100, for instance, or in this case, this tool is only, the flute's only 50. So I don't want to go too deep with it. So you can sort of limit it like that. I'm not going to specify that. I want it to go down to the bottom of that. So I'm going to say, okay. And then I'm going to resume my roughing sequence. So the last thing that we need to specify is the clearance. So if this tool retracts, how high should it retract? I want it to go about 20 millimeters above my job. So let me just show you guys like that. There it sits like that. Okay, so now I've specified everything, but you guys would notice I didn't do anything with the parameters. So by default, depending on your tool radius or your tool diameter, it will go and it will sort of calculate what the cut values should be, more or less. Okay. I'm not a big fan of that. I'll rather let me decide and then enter those values. It's very easy to go, I just hit OK, and then sort of have the wrong numbers in here. So depending on your setup, you might want to change this to 750 maximum step depth. We're using a big tool here, so I'm at least going to go 25. I'm going to make that maybe a little bit smaller, like 3-ish, just to use the flute spindle. 2,500, maybe not too bad. And then that's sort of that what I want to set. And then you can go into the feeds and speeds. How do you want to machine? Cut depths, cutting motions, all of that you can set in here. Okay, so there's really a lot of options. It doesn't make sense to go through them all in a webinar. It's just too much, and they sort of explain themselves. So I'm just going to stick to the defaults for now. And then let's view our toolpath. So it's quickly going to generate that. So you can see it's using just the normal. So it's not that nice preview we had with the solid tools, but depending on what you need and what you want, you can go and create that toolpath. So that 22 may be a little bit too small for this job. I need to maybe double up on that. Yeah, but there's our toolpath. So now you can view that. You can see this is a bad toolpath. We're jumping up and down all the time, in and out of the stock. That's not really what you want. You want it a lot more smoother. So default settings, not a good example in this case. So we might need to go and say, do like a constant load or maintain my cutting direction. Let's see what that's going to do for us. I don't want to spend too much time on calculating things. That's already a lot better. We're not jumping that much around. So now we can sort of refine the speeds and feeds for that. Okay, so let me just quickly. Okay. See, there's some nice questions coming in, so keep them coming. Too many now to scan through, but I might need to handle them afterwards. Okay, so let's say, okay, we're happy with that roughing cycle. Then we can go into our re-roughing cycle. It's exactly the same thing. You pick your tool. It's going to select the parameters. Maybe our raw stock allowance here should be a little bit smaller, like maybe 1 millimeter here. And then our roughing one should have been like 2 millimeters. So you're going to make them smaller. So, and then it needs to calculate that from the roughing one. So exactly the same thing that you're going to set. The only big difference between them is your how much stock they should leave on. And then if you go directly into a finishing, exactly the same thing again. You're going to tell it where do you want to finish. So maybe we just want to finish this. Maybe just this section over here. You can see there's a mole window, which means now this will only machine in that section. Just make sure my step over is not too small. Yeah, that should be fine. I don't want to spend too much time on calculations. Just to show you guys, you can see now it's just finishing that bottom section. Okay, so mole window is really an important part to just sort of narrow things down and then machining in that section. Okay, so we're quickly running out of time. There's one thing that I sort of want to end up with you guys. And so we talked about the workflow that you need to follow. So we're taking the part and then we design that, then we create our core and cavities from that part, and then we machine the core and cavities, and once the part changes, everything will update. Okay, so that's the typical workflow. But in Creo, nothing is stopping you to go outside of that. So I can create a blank NC assembly. I don't have to specify a reference. I can say, well, I've got a block. So this is your typical scenario where the guys come to you. we've got a scrap block. We need to machine a flange, or we need to drill some holes and just cut a hole into a piece of scrap material to fix a job quickly. Can you help us out? And you can say, yes, I can do that. So you just need to specify a stock just to do some sort of simulation. You don't even need that if you don't want to. And from here, you can go specify your work center. So my 3-axis machine is available. I need to drill some holes, or I need to create a coordinate system. I'm going to use the default one. So I'm going to use my default coordinate system. There's my block. So I'm using the center. So maybe the top would have been easier. We need to drill some holes. I'm going to use points for that. So I'm going to tell it that these holes need to be 50 from the center. Show that, and then maybe do a quick sketch. On top of this, we need to machine out the pockets. I'm just going to do a quick round, but I mean, this shape can be any shape if you want to. Okay, so let's quickly go and create those. So now we're going to go to our milling. I'm going to tell it, well, I need to specify a tool. I'm going to use the 12 tool, should be fine. Let's do that. 12 is fine. Clearance, I need to specify. I'm going to cut the curve. Pick the curve that you want to cut. Should it be an offset cut? Yes, I want to cut in the inside. Starting height should be there. And then I'm going to create a datum plane offset where the depth should be. So I want to cut that 30 deep. You can see we have some tool paths. Okay. Let's quickly do a drilling cycle. I need to pick a drill. It would be nice. Basic drill 13. Keep it default again. I want to select a point. How deep do I want that to be? I need to drill a 30 deep hole. Say okay. And let's do a simulation. So there we're cutting a groove. And we drill a hole without the part, without all the bits and pieces. So there is quick ways to sort of get a tool path onto a machine and quickly fixing a job. You don't need the whole workflow. It's easy to go in and just create those tool paths for whatever you need to fix a job or just to remove some material quickly. Okay, so that's what I wanted to show you guys. I'm quickly going to jump back to the slides because the next one is the questions. Just quickly want to tell you about our training capabilities. So we do virtual trainings, we do in-center trainings, so you come to us, or we do on-site training. So just give us a shout if there's any training needed. Quickly take a screenshot of my contact details. I see I have a lot of questions. If I'm not going to get to your question, drop me an email and then we'll handle it like that. Okay, so I'm going to mute myself quickly, go read through the questions and then answer them as we go along. Okay, so we have a question on how Creo will handle model errors. So if there's like gaps and things like that. So I assume you're talking about surface models. So surface models is a little bit more trickier. If it's a bad surface model and there's gaps and things like that, if it's outside of the accuracy, Creo is going to see those gaps and it might try to push a tool in there. but it depends on the accuracy. So you can play around with that and sort of fix those gap errors. But the best is sort of, it can be a surface model, but it should be a closed surface model. Those are the best. So I know it's not always easy with imported geometry, step files, IGES files and things like that. They can be a bit of a pain. But if you have to choose some sort of import geometry, always ask for step files. They a lot better a lot easier to fix in Creo, and the quality is normally much better as well. Okay, so yeah, model quality is important, but there are some tools and things that you can use to make your life easier. And make sure to view our Import Data Doctor webinar. That will give you tips on how to fix imported geometry or bad geometry in Creo. Okay, let me quickly read the next one and then answer that. Okay, so the question is, can we machine non-solid surfaces? So like just surfaces? Yes, we can do that. It doesn't have to be a solid. And then we have a question on model accuracy. Yes, model accuracy is very important because we are moving from a part design to a mold design or tooling design and then creating the tool parts. Everything should be the same accuracy as far as possible. It's when you're splitting components into cores and cavities, that's normally the first sign where you will get that accuracy is haunting you a little bit if it's not creating those split surfaces. If it's just pure machining, so you're creating a solid component, you're machining that solid, there's no tooling involved, then it's pretty straightforward. There's not really issues with that, but try to keep your accuracy consistent through the whole process. So we have a question about the material being visible during the toolpath simulation. I assume you're referring to the stock. So yep, that's the different the different simulation. There you can have stock, you can have your toolpath show, you can have different colors for your tooling. So yep, you can have that. Then the next question, are there default values for your RPM, feed rates, and so settings? Yes, there are out of the box things that you can use. Default values, it's just a setting you have to set when you sort of do your when you specify your cutting tools. So it will be a percentage of the tool diameter. It's sort of driven from that. That being said, you can also change those relations, so that will get you closer to your working environment. Yeah, but there's default values, and then how they are calculated, you can manipulate as well. Okay, so then we have a question about the tolerances. So Creo is going to use the geometry that's there. The tolerances comes in with the machining that you apply. So the NC toolpath is not gonna it's not gonna sort of use that in any calculations. So it's not going to use the tolerances. So it's going to look for the real world. It's going to be perfect scenario, like with any other design in Creo. If you say a hole is 5 millimeters and that hole is 5 millimeters, we all know on a machine that's going to be different. So, but no, Creo is not calculating for those tolerances when it's generating your tool paths. So model-based dimensions or model-based definitions, no, they are not part of the Creo toolpath generation, so it's not going to look at those. once again, you can get tricky and create parameters and things like that and then reuse that, but no, it's not really gonna make a big difference on the toolpaths that you generate. Then we have a question on chip load. Are there calculators for chip load? It's not calculators that you can use. You can use third parties software to do that, or you can sort of write a relation when you do the tooling. You can get those relations to be part of a specific tool, for instance. Save that tool and then sort of use a parameter to drive that chip load. So yes, not out of the box. We have to sort of write those relations, and then they're going to be different for each tool. So is there an easy way to handle all the datums and coordinate systems? I would use layers if it becomes a problem. So you can create layer rules and things like that to hide certain coordinate systems and then still show other coordinate systems. So use layers to control the datums and the coordinate systems that you want to see. I know when you have a lot of parts, they become a real problem. It's difficult to see what's going on, and the normal on and off will hide everything, and sometimes you still want to see one or two of those. So then layers would be the way to handle those. Then we have a question about, can we have access to the assembly file? Unfortunately not. It's demo data created by PTC, so I can't share that with everybody, but the webinar will be on our YouTube channel, so you can sort of view that. Take a good look at the model tree. You can learn a lot from just looking at the model tree, and then see the workflow, and then also you can see some of the parameters that was used that I've showed. So you can sort of replicate that, but no, unfortunately, I cannot share demo data. Can stock from a first operation be used? Yes, so you can save out your stock. So if you want to, when you do that, your roughing and you do your re-roughing, those stocks can be saved out. Sorry, I didn't show that when I did the simulation. Yes, I can quickly show it in this one. Operation. So here's the stock elements. So yeah, you can sort of save it out, save the stock model, and then you can also save it to your model tree, and then that's sort of just a visual for you to see where you are in your process. So okay, so I don't see any more questions coming in, and we are already over our time. So I want to thank everybody for joining us today. If there's any other questions that you think of, or if you need any help, please don't hesitate to reach out to me. I've got my contact details on the screen now. Take a screenshot of that, and then please feel free to reach out. And then again, thank you for joining us for today. Hope to see you guys soon.